Welcome to another edition of Comet Algebra. We are beginning Chapter 11. In the last chapter, we used trigonometry in right triangles. Well, what about triangles that don't have a right angle? We need to learn some more trig in order to deal with them. So first of all, some definitions. An oblique triangle is defined to be a triangle without a right angle. An identity, now this term, we're defining it now, we're not going to deal with it much until section 3, but it's simply an equation that is always true for all values in a domain. An easy example of an identity is if x is any number, if we took x times 1, we would always get x. Just an example of an identity. So the first thing we're going to do is learn a way to find the area of a triangle when we are not given a height, when there is no right angle. So we're going to derive this using the sine. So the first thing I'm going to do is draw in an altitude or a height, and we'll label this the letter H. Now, one thing you need to recall from geometry, or learn it now if you have not, we are going to label the angles of a triangle with capital letters, and we're going to label the sides that are across from them with the small letters. So the side that is across from angle A is little a, the side across from angle B is little b, and likewise across from angle C is little c. Now I'd like you to recall from your geometry days the area of a triangle is 1/2 base times height. But as I said, we're going to find a formula that will work when we do not have a height. So we need to take this formula and manipulate it and do some substitution so that we do not have a height in it. So let's start by looking at the sine of angle A. The sine of angle A in this little triangle that we've drawn here, angle A is right here, H is opposite from angle A, and C is the hypotenuse. So the sine is H over C. And now if we solve this for height, if we multiply both sides by C, I get height equals C times the sine of A. And now if we do a substitution, if we take this H and we put it in to the original area formula right there, then what I'd end up with for the area of the triangle is 1/2, the B is still in there, times, and now this part, the C times the sine of A. And this is a new formula that you're going to be working with to find the area of a triangle when we are not given a height. It is very important for you to notice that when using this formula, we have the sine of angle A, so here's angle A, and the other two sides, B and C, are the two sides that make up the angle. There's C and there's B. So when you use this formula, please note that the angle that you're using is in between the two sides. And that's what I noted right here. This is very, very important, that the angle is in between the two sides. So I wrote this 3 different ways, but it's really the same thing repeated over and over again. Because angle A is in between sides B and C, likewise angle B is in between A and C is between the two sides A and B. So you really only need to write this down once, but please make note of this. All right, let's look at an example. Here, in order to use the angle area formula, we need to have side, angle, side, and we do have that. In other words, the angle has to be between the two sides, and then this formula for area works. Even when you do not have a height, there's no altitude, there's no 90 degrees, but we can still find the area. So the formula says we take 1/2 times the two sides that surround the angle. So I have 1/2 times 6 times 4, and then I need to multiply by the sine of that angle. So sine 30. So if you pick up your calc and multiply this out, and times the sine of 30, you should get 6. And then since we are given the measurements in centimeters, the area measurement is in centimeters squared. All right, this is the second part of the section, the law of sines. In class we did a worksheet where we derived the law of sines, and we found that it is true for any triangle that the sine of this angle divided by the side opposite it equals the sine of this angle divided by the side that's opposite it equals the sine of this angle divided by the side opposite. These ratios are all equal. This is very, very important. Write this down in your notes, and we're going to learn how to use it. Please note that the law of sines works, and we use it to solve triangles when we're given either angle, angle, side, or angle, side, angle, and then we're only going to do some of these cases, and sometimes side, side, angle. Now the reason I wrote sometimes is because you'll remember that side, side, angle did not work to prove triangles congruent when you were in geometry, because sometimes this will make a triangle and sometimes it won't, because one side will be too short. In Algebra 2, we are going to deal with this case when the triangle does exist. So if I give you a picture with side, side, angle, the triangle exists, and we will be using the law of sines. In this example, the directions say solve triangle XYZ. Let me change that. That should say solve triangle ABC. In other words, find all the missing sides and find this missing angle. So it looks to me like the easiest way to start, we have two angles. Simply subtract from 180, and we would find that angle C is 80 degrees. And now we need to find across from angle A is side small a, across from angle B is little b. So the two other pieces we need to find here are sides A and B. And we can use the law of sines because we have angle, side, angle. And the way we set up this ratio is out of the 4 things in the ratio, you need to know 3 of them. So we do not know little a, but we know angle A, and we also know little c and angle C, so let's use that to set up a ratio. So I have sine angle A, which I guess I should just write sine of 70. So sine of 70 over little a, I do not know, equals sine of angle C, sine of 80 over little c, which is 5. So I plugged in the 3 that I know, and we can use the cross multiply strategy. So if you take sine 70 times 5 and then a times sine 80, we need to divide both sides by sine 80. So the work on the calculator to find your little letter a becomes sine 70 times 5 divided by sine 80. Punch that out on the calc, and then for letter A we should get, and I'm going to round off to the nearest hundredth, 4.77. So we found that. Now we need to use the law of sines again to find our little letter B. So opposite B is the 30-degree angle. So we write sine 30 over B, and it doesn't matter which one you use. You can use A or C. I guess I'm just going to use C. So we have the sine of 80 over 5. And again, calculator work, sine 30 times 5 divided by sine 80. And for letter B, you should get 2.54. We'll write that in over here. And now the triangle is solved. Okay, that's all the notes for 11.1. Have fun with the law of sines.